Okay, Algebra 2 students, here's a video for example 5 for section 3.5. We're going to solve some polynomial equations. What are the solutions to this cubic equals this cubic function? First of all, we want to set it equal to 0, so then we can just tackle it like we have some recent problems. So they have subtracted the 2x cubed and subtracted the 5x squared and added the 3x to both sides, and they got this. I cannot highlight that, I apologize. They noticed something that I wouldn't have noticed. I would have had to look it up in our notes, but they found that x cubed plus 3x squared plus 3x plus 1, they notice it's a cubic, it's a cube of a binomial. So they set x plus 1 cubed equal to 0, took the cube root of both sides, and then subtracted 1 to get x is negative 1. I don't think I would have noticed, but now that they've shown me this example, I'll look for that in the future. Too bad they don't give us more to practice with, so I'm going to just go right into solving this next one. If you want, you could give it a shot, but I think we should have more practice. I want to either subtract everything from this side to bring it over here, or everything here and bring it over there. I think I will do what I said first, because there's less terms over here. So if I subtract x cubed from both sides, oh cool, the x cubes are going to cancel each other out. And then I'm going to add 7x, and I'm going to subtract 6 from both sides. And when I do that, I have 0 equals, that's not a very good 0. I'll have 0 equals 5x squared plus 5x minus 30. Alright, I notice they're all divisible by 5, so if I divide both sides by 5, I'll have 0 equals 1x squared plus 1x minus 6. And that's going to work out nice. I can factor that. If I didn't notice that it factored right off, I could do the quadratic formula. But I noticed this is going to factor into x plus 3, x minus 2. And that tells me the two roots to this, which would therefore be the answer to the original equation, are negative 3 and positive 2. Let's see how I did. The answers are negative 3 and positive 2. All right, let's take a look at this next one. This one is a quartic function, and this is a cubic function. Again, I would want to set it equal to 0 and then see what I can do with it. Click pause if you want to give it a shot, or just watch me attempt. This is the highest exponent. It's positive, so I'm going to keep this side. I'm going to bring these things over by adding the x cubed to both sides and adding a 2x to both sides, so I'm going to end up with 0 on this side. If I add x cubed, I'll still have the x fourth. I don't have any cubes, so it's going to be plus x cubed. I have 2x squared. I might have written this too close. I don't know if I can fit this in. And I added 2x to both sides, so plus 2x. Okay, let's see if I notice anything I can factor out. Sure, I can take an x out, or I could solve it by grouping. Tempting. I think I will try to solve by grouping. We haven't done that in a while. What do I notice? I noticed that I can factor out an x cubed out of that, so I'm going to x cubed, and what I'm left with is x plus 1. And then out of this, I can factor out a 2x. So I'm going to factor out a 2x. And what I'm left behind with is x plus 1. Darn it, I should have factored an x out to start with. I just noticed that. these all have x in it, so I should have taken an x out. Shall we pretend I did that? That might confuse you a little bit, so let's just keep going with this. So I have this quartic function breaks into x cubed plus 2x. If you remember how to the next step on factor by grouping, times x plus 1. And now I guess I'll factor out the x. So I have an x as one factor. I have x squared plus 2, which is going to have imaginary roots. I'll get back to that in a minute. And I have x plus 1. So if I set these all to 0, I can get some roots. One root's going to be x equals 0, so there's one of the roots. This one, x plus 1 could equal 0, so that's negative 1 is one of the roots. This one's a little trickier, so let me do that one up here. X squared plus 2 could equal 0. And if that's true, I could solve this one by subtracting 2 from both sides. We have options. I mean, I could have done some other things earlier on. I guess I could have used a graphing calculator and just saw where they crossed. X squared equals negative 2. Take the square root of both sides, and I'm going to get x equals positive or negative square root of negative 2. Well, that means it could be positive or negative. I can factor out the I times the square root of 2. So there's 2 of the roots, and here are the other 2 roots. So there's 4 roots. Let's see what they write. Negative 1, 0, positive and negative I square roots of 2. Okay? You should be able to do the following problems: 11, 19, 20, and 21. That's it for this video. Have a great day.